So when you're answering questions about the fundamental theorem of calculus, there are all kinds of tricky little ways that it can be presented to you. And what we're going to see is we're going to see this section in the notes where they found another one of these tricky ways to point it out to us. And so let's see what we can do with it. So here they're telling us, so this is, remember, this is the graph of the function f of x here, little f of x. And so now they're bringing in the notion of this big F of x. So they tell us that big F of 0 is equal to 5. And they tell us that big F is an antiderivative of f of x. I should be clear here, or clarify the notes that somebody else wrote. This is an antiderivative of f of x. It's not the only one. Remember, we've always put that plus c in our antiderivatives because there are an infinite number of antiderivatives. But this is the antiderivative that where f of 0 is equal to 5. And so they want to know what big F of 3 is equal to. All right. So let me remind you, let me tell you that the next thing that I write down on this page is going to be the fundamental theorem of calculus applied to this problem. So see if you can come up with what I'm going to write. And then if you're feeling really saucy, you can see if you can go ahead and solve it based on that. All right, so remember that the fundamental theorem of calculus says that the integral from 0 to 3, these are the two numbers that I'm obviously interested in for this problem, of little f of x dx, since I know that big F is an antiderivative, it's equal to big F of 3 minus big F of 0. All right, so all I did is wrote down the fundamental theorem of calculus there. So how does that help me to solve this problem that they're asking? Well, it's interesting because they want me to figure out what big F of 3 is. And they've told me what big F of 0 is. And we know what the definite integral from 0 to 3 of little f of x is. So let's substitute in the values that we do know. So this is saying that 2.5 plus pi is equal to big F of 3, which is what they want us to find, minus 5. F of 0 is equal to 5, and the definite integral of little f from 0 to 3 is 2.5 plus pi. So to solve for this thing that they want us to find, all we need to do is add 5 to both sides of the equation. And we get that big F of 3 is equal to 7.5 plus pi. In the real world, you're not going to see a problem offered to us quite this awkwardly, but we will see real world problems where this comes up. In fact, we kind of already did. Remember that problem where we talked about the height of the shrubs that were growing over a 5-year history. And so they told us the height of the shrubs when they were planted. They gave us the growth formula, and they wanted to calculate the height of the shrubs when they were sold. And so that was really just this same process that we were going through. Okay, except that was in a real world scenario, and this is more artificial. So give this last one a shot here. If f of negative 2 is equal to negative 2, what is the value of f of 2, where f is the antiderivative of f of x? Woof. All right, so maybe this is a little hard because we don't know. Well, we do know here. All right, so we've got, let's see what we can set up. We're going to set up the same problem we did here, except we're not going to use the numbers 0 and 3. What numbers do you think we should use? Well, the two numbers that are interesting as far as the values of big F are going to be negative 2 and positive 2. And just to save myself a little grief, I'm going to put the lower one down there and the upper one up there. So that's equal to f of 2 minus f of negative 2. All right. So now I need to calculate this definite integral from -2 to +2 of f of x dx. How do I calculate that? Well, all I know about f is really quite a lot, is this function here. So the definite integral from -2 to +2 is the area under the curve between the curve and the x-axis from -2 to +2. And so this is pi and 2, and over here is another pi and another 2, because this is an even function. So that area, and therefore that definite integral, is equal to 4 plus 2 pi. F of 2 is what we want to solve for, and f of -2 is something they already told us. All right, so once again, we isolate the f of 2, big F of 2, and we get that that's equal to 2 plus 2 pi. Okay, so that kind of tells us that this gives us the power, being able to understand uh, the definite integrals of a function, lets us have some understanding about the values of an antiderivative. As long as we have the value of that antiderivative at some point, we can figure out the other one using the fundamental theorem of calculus. So once again, this kind of gives you an example of how we're combining our fundamental theorem of calculus with calculating geometric areas in order to solve calculus problems. All right, so this was a pretty short day worth of notes. I probably should have tossed it into the last unit, but I didn't. So just wrap up this homework. It should be pretty quick and simple for you, I'm hoping. So let me know if you have any troubles with that.